Welcome to IT Learning, the place where everyone can learn the basics of the IT world. Today's topic is subnetting. Subnetting, in its simplest form, is the process of dividing a network into smaller, more manageable parts. Think of it as slicing a large pizza into smaller pieces. Each piece is still pizza, but it's easier to handle and distribute. Subnetting is an essential concept in the world of IP networks. It helps in enhancing network performance, improving security, and simplifying management. So whether you're an IT professional, a budding network enthusiast, or simply someone interested in the backbone of the internet, understanding subnetting is a key piece of the puzzle. It's true, delving into the world of subnetting can be a bit daunting at first. The numbers, the terms, the calculations, they all may seem overwhelming. But remember, every expert was once a beginner. Subnetting may seem complex at first, but once you understand the basics, it becomes a lot more manageable. Before diving into subnetting, you need to understand IP addresses. An IP address, short for Internet Protocol Address, is a unique identifier assigned to each device connected to a network. It's like a postal address, but for your devices on the internet. The structure of an IP address is composed of 4 sets of numbers, each ranging from 0 to 255. These sets are separated by periods, forming a pattern like 192.168.1.1. But why do the numbers only go up to 255? Well, that's because IP addresses are based on binary numbers, the language of computers. You see, binary numbers consist of only 2 digits, 1 and 0. Each digit is called a bit. 8 bits make a byte, and each set of numbers in an IP address is 1 byte. When converted to binary, each byte ranges from 0.0.0 to 1.1111111, which in decimal numbers, our more familiar number system, equals 0 to 255. The IP address system we've just described is called IPv4, or Internet Protocol version 4. There's also a more complex system called IPv6, designed to accommodate the ever-growing number of devices needing unique addresses. But let's stick to IPv4 for now. Now, why is every IP address unique? Because each one points to a specific device on the internet. Just as you wouldn't want 2 houses with the same address, you wouldn't want 2 devices with the same IP address. It's how data knows where to go when it's sent across the internet. Understanding IP addresses is key to grasping subnetting. Now let's move on to what a subnet is. So what exactly is a subnet? Well, think of a subnet as a smaller network within a larger one. It's like having a private neighborhood within a bustling city. This division allows for better organization and control of data traffic. Now, why do we need subnets? The answer lies in the efficient use of IP addresses. Imagine you run a company with various departments, each requiring its own network. Instead of assigning a unique IP address to each device, you can create subnets. Each department becomes its own subnet, sharing a range of IP addresses. This not only conserves the number of IP addresses used, but also makes the network easier to manage. Subnetting also enhances network performance. By segregating the network into smaller parts, we reduce traffic congestion and increase network speed. Subnetting can help manage network growth and improve network performance. But how do we create subnets? That's where the subnet mask comes in. Now that we know what a subnet is, let's talk about subnet masks. A subnet mask, just like an IP address, is a 32-bit number. However, it serves a distinct purpose within the realm of networking. The subnet mask's role is to identify the network portion of an IP address. It works hand in hand with the IP address to divide a network into smaller, more manageable parts, or subnets. But how does it do that? Well, let's delve a bit deeper. A subnet mask is composed of 2 parts. The first part, filled with ones, represents the network portion. The second part, filled with zeros, represents the host portion. When we say ones and zeros, we're referring to the binary form of the subnet mask. In binary, a 1 indicates that the corresponding bit in the IP address is part of the network address. A 0, on the other hand, indicates that it is part of the host address. Let's take an example. Consider an IP address of 192.168.1.5 and a subnet mask of 255.255.0. Now the first 3 octets or sections of the subnet mask are filled with ones in binary. This means that the first 3 octets of the IP address represent the network address. The last octet of the subnet mask is filled with zeros, indicating that the last octet of the IP address represents the host within that network. In simpler terms, the subnet mask helps devices determine whether an IP address belongs to the same network or a different one. When a device needs to communicate with another, it compares its own network address with the network address of the destination IP. If they match, the device knows that the destination is on the same network. If they don't, the device knows it needs to reach out to a different network. The subnet mask is a crucial component of subnetting. It helps devices determine whether an IP address is on the same network or a different one. Subnetting is a fundamental concept in networking that you need to grasp. It's like a giant puzzle that needs solving, and each piece is critical. Remember, subnetting is all about dividing a network into smaller, more manageable parts, called subnets. These subnets are defined by their IP addresses, unique identifiers that allow data to be sent and received accurately. Now let's not forget about the subnet mask. This is the secret code that determines which part of the IP address refers to the subnet and which part refers to the host. It's like a guide that helps navigate the world of IP addresses and subnets. To truly master this, you need to roll up your sleeves and dive in. Practice creating your own subnets and see how the subnet mask changes. It's a hands-on process that will cement your understanding and make you a subnetting pro in no time. To continue learning new IT knowledge, feel free to subscribe and leave a comment about which topic you'd like a video on.